Hello, my name is Martin Rauch. I'm working for Siemens Corporate Technology, and in my presentation I will give you, or we will speak about our experiences with the Identity Authority Manager during our pilot project together with PrimeKey. An important topic for Siemens is to make its products secure. One important piece to prove the originality of and allow secure communication in a customer domain are manufacturer device certificates. I found this interesting sentence on the DigiCert webpage, which tells the importance of certificates for devices. So it says that a device certificate creates an identity for each thing in an IoT ecosystem, making sure each device authenticates as it connects and protects communication between devices. And I think it's very important in a factory site or in an industrial plant that components can identified and communicate securely with each other. And that is also reflected by a growing number of standards which requires manufacturing device certificates. For example, 802.1AR or LTE or PrimeKey, which forces that pledges, which is in that term, devices have an IDEF ID, which is nothing else than a manufacturer certificate installed before it is implanted into a factory. Main purpose of the manufacturing device is to prove the origin and the identity of the device during onboarding and integration into a new ecosystem on a customer domain. Therefore, we have established a central service and at Siemens the product PKI service, which enables the Siemens business units to imprint devices with manufacturer device certificates during the production, and in a fully automated way and directly on the production line during the production of the device. The certificates imprinted then are standing for the origin, prove the origin as it is an origin Siemens device. And yeah, so here you see that what we already established as a central service. So we have on the left-hand side that segments located in a really secure, high secure environment in the Siemens Trust Center. Have an offline root system where the root key or the keys for the root CAs are hosted. We have that issuing CA system, which is in a dedicated network zone with other components for CLs hosting and OCSP requests, and request gateway, which receives requests from the factories and the connected sites. And we have also established a service for digital signature. That was all done together with PrimeKey in the last years. And on the right-hand side, we have a lot of we have the customer sides where the customer was until now responsible to build up a secure PKI infrastructure for their usage and for the requesting of certificates and digital signatures. So main components on the right-hand side are an LRA, local registration authority, which mainly is located directly on the production line, and a registration authority which might be placed between the production network, which is restricted from access to from the outside and only allows dedicated connection to the outside, and the Siemens network where the trust center then is located. So the RA is the bridge between the LRAs and the trust center or product PKI service. That was until now in the responsibility of the customers for using the product PKI service. And here you see a more dedicated or an example of how a typically factory site is built up until now. So we have devices in production which are directly connected to the LYRA, and this devices does not have an identity so far. It just receives the information which builds up its identity, like a serial number, a MAC addresses, and from that information, its identity is built, but it could not be proved by that device in production. Therefore, the LYRA has to build to affirm the requests received from the certificate from the device, or it can also build the certificate request for the device and affirm that it's the real identity of the device to the CA system. And therefore, the LYRA either forwards the received CMP or, for example, CMP request from the device, or it builds up on such a request and forwards it to the array or directly to the issuing CA. And the array between the CA system and the LYRAs has the task to validate and validate the incoming requests from the LYRAs, and maybe also check against the production database if everything is correct and if the device is really in production and the information in the request are corresponding to the information from the production database. And maybe the production database is also connected to the LYRAs if maybe not all information can be received from the device, and the LYRA can also request information from the production database. That's typically set up we have on the customer side from the product PKI service, and that also have some challenges here for the customers to build up such a PKI infrastructure. So the production processes are very different from site, may also differ from site to site, from business units to business units. So sometimes there's a production database that differs what information are received from the production database, and also the connection type to the database differ. And yeah, another point is a key generation. So some devices are able to generate keys by themselves. Other devices are not able to produce or generate own keys. So the LYRA has to take over that part to generate also keys for the device before requesting the certificate. The communication between the LYRA and the device are very different because every device has a specific communication protocol, for example. So it comes from TCP to OPC-UA. Some devices are able to create a CMP request by themselves. Others have just a REST API or something else. So the communication between the LYRA and the device are very different and sometimes also proprietary. The LYRA, which is placed in a production environment, must be easy to operate and maintain. So the people in the production site might not have or have only limited IT and PKI expertise. So therefore, the operation and maintenance must be easy for such an LYRA. Security is an important topic also here, because we don't have here a high secure data center. We have a production site with many people around, with not really access control. The LYRAs might be accessible by a lot of people, and so the security aspect is very important. As I said, it's an industrial environment. The requirements to the hardware regarding dust, temperature, and vibration different to a location in a data center. Okay. And that leads, or that is in the problem with that thing was that it creates high effort and costs for the customers to build up such a PKI environment. And for each customer, the problem was that he has to start from scratch because of very different requirements and different protocols used for the communication with the devices. And we from corporate technology as governance for the product PKI service noticed that it's a high barrier for new customers to use the PKI service because of that high costs and efforts to build up such an infrastructure. Therefore, we started to discuss with the existing customers about how a generic solution could look like. What are the requirements for such a generic solution? How to make it easier for new customers to build up such a PKI infrastructure. So main points from that requirements analysis was regarding operations, that such a component should be remotely administrative, that it has to be unattended operated. Logging and monitoring was an important point. And also from the security perspective, key storage in a hardware module. As I said, it's an open production environment. As keys has to be stored in a hardware module. Separate network interfaces would be important because of the one thing to communicate with the devices in production, and one interface, for example, for the communication to the CA system, and the authentication and authorization for administration users. From the hardware perspective, on the left side, we have, as this is an industrial environment, and with a requirement for an industrial PC, which covers the protection against dust, temperature, and vibrations. And it should be also mountable to a top head rail, on top head rail. And from the functionality, the device interface has to support a wide range of communication protocols to the device, and in some cases it should be easily to be adapted to customer device connector, to specific customer device connectors. The upstream interface should support standard enrollment protocols like CMP. It has to support TLS authentication to the CA system, and also cascading should be possible. So we have that LYRA hierarchy structure here. So cascading was also one point. And from the workflow engine, so it has to be easily adapted to the processes in the factories needed. For example, a connectivity to external database, and also message protection was one important point we identified such a solution should have. So we started, after the discussion with our customers, we started discussion also with potential partners, and PrimeKey was one of the best partners we had so far, and they were willing to start a project with us for the development of such a base component for industrial PKI infrastructure. And from the development was done or was targeted from PrimeKey side, and from Siemens side there was 2 factories which was willing to participate in such a pilot project, but regarding that requirements I showed before, there was additional challenges in that project we faced before starting. There was a really tough schedule for that pilot project, so we started the discussion in beginning of last year, so in the beginning of 2019, and the development project was then started mid of 2019. And the first usage of the ID Outman was planned for end of October 2019, because there was production start planned for that, where the ID Outman should be used. The 2 factory sites also have different requirements because they are producing different kind of devices. So there were just different requirements regarding the communication protocols and so on, and the connection to the external database were different. So that was also a challenge for that pilot project. And another point was also what was faced during that pilot project was the integration into the factory IT infrastructure. So as I said on the beginning, production environments, production networks are very restricted. So it's only allowed to communicate components in the production environment, and only some components are allowed to go outside. And therefore, it was a really difficult to get the ID Outman into that infrastructure, because of also that the production network was managed by different units, as the production people involved in that project are assigned to. And as I said, one point what was also challenging was that connection to that internal production database, because it was very specific to that production side, and it's using a proprietary protocol for the requesting the information from the production database. So, but nevertheless, the pilot project was started last year, mid of last year, based on a Siemens industrial PC, as you see here. PrimeKey installed an IoT platform, ThinkSpot, on it, used as a workflow engine. And yeah, during the last 12 months and during that pilot project, it was tested not only on the 2 sites which was assigned to the pilot project, we also other sites from Siemens tested it, and yeah. So maybe that is just to give you an overview what PrimeKey does for that pilot project. There's a picture I took from the presentation from Andreas Phillips' webinar, so showing the architecture of the ID Outman. So you see on the top that 3 virtual machines, the main components of the ID Outman. On the left-hand side, that is the device adapter responsible for the communication to the device, which supports the different or necessary protocols like CMP, REST, and it's also customizable via scripts. In the middle, the yellow topped box is a workflow engine. That's a IoT platform. That's a ThinkSpot, which has a rule engine on the implemented, where you can design your process flows and so on. And on the right-hand side with the red top, it's a trust service adapter, which is responsible for the communication with the CA system. Everything is based on the Prime LFS, the Linux distribution from PrimeKey, which is already used for the PKI appliances and the SAA platform, the appliance. And that gives the possibility to use that backup and update mechanisms also from that already proved appliance platforms. And that gives also the great advantages to that ID Outman. And on the lowest, or on the basement, there's a trust anchor, which is responsible for storing the credentials and the communication to the hardware security module. So that's an abstraction layer for the hardware security module. So that just gives you the overview. And here is I have also an example for such a rule chain where you can define your production process or workflows. So here's in that example is just a really rudimentary basic flow where a message is received from the device. It's sent to the trust anchor for signing and approving. Then it's sent to the trust service adapter to be sent to the CA system, and also the trust service adapter receives the response from the CA system, and that response is then sent back to the device adapter to the device. That was what PrimeKey built up for the pilot project and what was implemented in the Siemens factories. And in the end, the challenges from the real tough time schedule was held, and the production could start in October. And I got a feedback from the responsible test engineer which was involved in that project, and he said that the work with PrimeKey as a partner in that pilot project was very result-oriented and efficient, despite the time pressure and adverse conditions like Corona. It was really a good thing to work together with PrimeKey in that project. The give and take on both sides contribute mainly to the success of the project. So that's what I also get the impression that every participant in the project was really result oriented, and every member of the project wanted really to complete the project in time. And yeah, so the main success factors from the pilot projects were the definition of real life requirements by the Siemens teams. So Siemens teams really support in what they need in the factories. The PrimeKey guys were very responsive and give really every time a really short in a short time an answer to the problems, requests, and the issues. And it was really goal oriented. Everybody all worked together to achieve the result in the given time. Okay, so in the end, the pilot project was successful, and the ID Outman was installed and is working on the side. But still, so many interesting features in the backlog, because it's at the moment it's in a prototype, and we are waiting for the release, or when that presentation is held, the first release would be out, and it's very interesting to see how many features are already in and how many features will come in future. So we are still waiting for some points, but I think the main goal to get production ready is achieved, but some points like logging monitoring and key storage and the support of the lightweight CMP profile and support of digital signature requests are still on the roadmap. And we are really waiting and hoping that it's soon done. But as our experience with PrimeKey so far, we are sure that they will come and it will be a great success, hopefully also for PrimeKey as it is for Siemens at the moment. Thanks.
Great, thank you. So let's see if the technology allows us, if we have Martin online. There you are.
Hello, Martin.
Greetings, hello, can you hear us?
Hi, here's Martin. I can hear you, yes.
Great, Martin. Thank you for a great presentation. We do have some questions that were sent to Thomas. Thomas, maybe you can...
We'll start with the chat.
Mm-hmm.
So, congratulations for pulling up a complex project like this. You mentioned the factory sites had very different requirements. Do they need to be also in sync with each other in some way, or were you able to isolate them and manage them as two separate projects?
There was more or less two separate projects or sub-projects, let's call it that way, because the workflows are very different in the Z factories. And that was also the reason we looked for a solution which is very flexible, which can be adapted to the needs of each factory. And I think with that approach, with that workflow engine, from that IoT platform, it is a real good solution for that, to be really flexible and be adaptable to the needs in the factories.
So, Evan, regarding say, trusted factories, are Siemens only operating trusted factories, so to say, or do you have also factories who you don't trust really to do the right thing?
Yeah, we have. So not only Siemens operated factories, we have also third parties which produce devices in the name of Siemens. So that's also the case. And yeah, maybe that is not so trustworthy than a Siemens factory. We have really everything under control. But I would not call that we really have untrusted factory somewhere. But we have Siemens factories which are controlled by Siemens, and we have factories which are third-party factories which are not controlled, and maybe you have to take more care for that third-party factories than Siemens. But from my perspective, both are similar and both has to be care about security, and we are really speaking about device certificates which are issued in the name of Siemens.
Yeah, thank you. So another question here. Sometimes manufacturing sites have unreliable connectivity, which can affect the production if it relies on being connected to a remote CA. How did you cover this use case?
Luckily, for the moment, we don't run in that problem. So we have factories not only in Germany, we have factories over Europe and also in Asia, which using the central service. And until now, we could say, okay, there was no connection problem.
Very impressive.
But there's one factory which has an hardware option which they can use if a connection to the central service is not working. They have a local CA system here for emergency cases. That is one possibility. But they never used it until now, so luckily, hopefully it also stays that.
Well, it's best if your backups don't have to be used.
Yeah.
So sure. One more question which I have here. Did you say, assuming that the factory environment is quite different from the normal IT environment, did you encounter any unexpected topics when putting the LRA or IDAM in the hands of the factories?
I would not say unexpected. So it's very different because normally in a data center you have access control, only trained people can operate it, and so And in a factory environment, you have a lot of people running around and taking care for some stuff. And they are not all IT people, and yeah, that's different. But for the moment, I could not think about an unexpected point.
You think of everything. That's when you're the best.
Yeah, obviously, if he's really thought about everything, it comes up in the end.
Yeah.
So I would like to apologize you again. I screwed up on the video. I hope that presentation for you in the audience was audible enough. And also, of course, you can post your questions on the chat furthermore to Martin. Martin, thank you, and beers on me next time in Stockholm.
Okay, thanks a lot.
Thank you.
It's a pleasure to be here.
Thank you. It's our honor.
Thanks.